Hello, sir. Today, me and my teammate Varun, we are presenting a deep dive on a Wireshark tool. Wireshark. So the agenda is we are going through a deep dive from the introduction to how an input and output of the captured data is done in Wireshark. So coming to the introduction, what is a Wireshark? It's a free network protocol analyzer that runs on Windows, Linux, and Mac computers, and it can be found on their official website www.wireshark.org. Uh, Wireshark, this is an open source project under the GPL, and all the code is source code is freely accessible. Hence, adding new protocols to Wireshark is fairly simple, and it is frequently done by the users. So basically, a packet sniffer records or sniffs packets that are transmitted or received by the computer. It then usually stores and shows the data included in the different protocol fields or recorded messages. So a packet sniffer isn't it's passive, so it never sends any packets. Instead, it just watches the messages that are delivered and received by the protocol and apps that are operating on your computer. Whereas a packet analyzer, it shows the contents of every field in a protocol message, and it is the second part of a packet sniffer. The packet analyzer needs to understand the structure of every message that is passed between protocols to accomplish this. So the features of Wireshark are it is accessible on both Windows and Linux. It records packets in real time from a network interface, and it opens file containing packet data from various packet capture applications such as Wireshark and TCP dump or Windows dump. The packets can be imported from text files that hold hex dumps of the packet data, and it shows packets with extensive protocol details. We can save the collected packets, export them with uh, with various capture file formats, and we can filter packets using a variety of criteria. Depending on the filters, colorize the packet display, make a range of statistics, and so on. So the installing procedure of the Wireshark is of going to the website www.wireshark.org, and then navigate to the download section, and then we have to choose whatever operating system we have. Then download the installer, run the installer, and follow the on-screen instructions, and install all the components like the WinPcap or NPCap if prompted, and then launch Wireshark. So once we launch to the Wireshark, the interface is, let me log into my VM. So in my command prompt, I'm just typing Wireshark. So which will launch the Wireshark page, and this is the interface of the Wireshark when we launch it. So some of the interfaces which Wireshark has, the status toolbar which shows the file, edit, view, capture, analyze, and all the required things which we need to, all the required tools which we need to have when we do the packet capture. Uh, these this is the status toolbar. So first the file menu, it manages program functions such as existing, saving, printing and exporting the capture files. It also allows to open and combine various capture files. When it comes to the edit menu, it handles packet search, configuration files, packet marking, time references, cut, copy and paste are not enabled in this edit menu. When it comes to the view, it manages the display of the recorded data, offering options to colorize the packet, resize information windows, zoom in, zoom out. And when it comes to Go, it contains elements for sending data to a specific packet. The capture menu allows adjustment of capture files and initiation or termination of captures. The analyze menu, it enables the TCP stream following user specific decoded settings, protocol dissecting, toggling and working with display filters. In the statistics menu, it displays various statistics windows, including the protocol hierarchy and packet summary, providing a comprehensive network analysis. The telephony, it presents statistics related to telephony such as the flow diagrams, media analysis, or any protocol hierarchy statistics. When it comes to the wireless menu, it includes option to show the IEEE 802.11 and Bluetooth wireless statistics. The tools menu provide various Wireshark utilities, including the creation of firewall ACL rules. When it comes to the helps menu, it assists users with basic guidance, online access to web pages, manual help for command line tools, and so on and so forth. Uh, the Wireshark interface, it also includes a main toolbar. It quickly access to frequently used menu items is offered by the main toolbar. The user cannot edit this toolbar. However, if additional screen space is required to display more packet data, it can be hidden using the view menu. So some of the features this main toolbar allows is, um, when I want to capture packets using the Ethernet 0 interface, we can see that this menu allows us to start and stop, and this allows us to go back to the next packet. The left arrow allows us to go to the previous packet, uh, so on and so forth. So similar to analogous menu items, toolbar items will be enabled or disabled. For instance, the main window toolbar appears once a file has been opened in the picture below. So the stop capture button is disabled because no capture is underway, but other file related buttons are enabled. So, capturing the network traffic. This is one of the main features of Wireshark. The live capture function of Wireshark is crucial for real time network analysis. With features like capturing from numerous interfaces at once and different hardware types, this capture engine enables versatility. The users can set up their triggers like packet data, data quantity, or time length to pause captures. Concurrent analysis is made possible by Wireshark's real time display of decoded packets. Users can also rotate between files during lengthy captures, and they can filter tool helps limit the amount of capture data. Uh, it is not supported, nevertheless, to halt captures based on the content of collected data. So the welcome screen appears when you run Wireshark without an active capture, which I just showed you. And then once we select any network interface, then it starts to capture the network packets on that particular interface. So the beyond the interface, the network interfaces, Wireshark also extends to capture Bluetooth, USB, and other packet types for comprehensive analysis, network analysis. It is also possible to restrict the packet capture in Wireshark to only those that match a capture filter. The libcap filter language is used to write Wireshark capture filters. So Nmap for network exploitation. Nmap is a widely used tool in the industry for network mapping, live host detect identification, and service discovery. So some of the most popular Nmap scan kinds are the TCP connect scans, SYN scans, and the UDP scans. Understanding how Nmap scans operate is crucial for identifying scan activity on the network. Without the appropriate filters, it is also impossible to comprehend the scan information. So the first scan is the TCP connect scan. Uh, it depends on a three-way handshake, so it must finish the handshake process. Usually, to execute the TCP scan, the command is nmap uh, hyphen s capital T, and then the host name or the IP address on which you want to do the scan. So this is only available to non-root users, and this is used by non-privileged users. Because of this nature of this protocol, it typically has a window size larger than 1024 bytes. So the order of the three-way handshake via TCP connect scan is shown below in this image. If it's an open TCP port scan, then uh, it must complete a three-way handshake, which is the send packet, send acknowledge, and acknowledge. So the closed TCP port scan, it just need to send a send packet and then reset and acknowledge. So going to the tool and executing the TCP connect scan. Just giving a port range of 1 to 100, so it will be easy for me to look through the packets and analyze the three-way handshake. Sorry for the typo. Okay. Once I started the Nmap scan, going to the Wireshark. So the Wireshark is capturing the packets on my network interface Ethernet 0. Since it's a TCP connect scan, I want to analyze the TCP packets for three-way handshake process. So in the display filter, I'm just typing TCP and filtering out all the TCP packets. So the packet number 58, 59, and 60 shows the three-way handshake. First, a SYN packet is sent from source to the destination, and the destination sends back the acknowledgement along with the SYN packet. And then the uh, uh, source confirms that it has received the acknowledgement packet. So uh, this completes the three-way handshake for the TCP connect scan. So the next scan is the TCP SYN scan. In the TCP SYN scan, it is not dependent on a three-way handshake, which means the handshake process need not be completed. So the command for this is usually nmap ss and it is utilized by individuals with privilege. It typically has a size of 1024 bytes or less because the request is incomplete and it doesn't expect to receive any data. Generally, this is the format of the TCP SYN scan. In the open port, it just sends an acknowledgement SYN packet, and then the destination sends back a acknowledgement packet along with the SYN, and then the source just terminates the session, or uh, it continues. So basically, it doesn't complete a three-way handshake. Going to the VM and executing the uh, TCP SYN scan, since it requires a root privileges, it asks for the password, and you can see that the SYN scan has already started. Now going back to Wireshark and acknowledge looking for the packets. Starting a new session on the Wireshark. So the TCP, I did a TCP closed port scan which shows just the SYN and reset acknowledge packets. Moving on to the next scan, UDP scan, it also doesn't require a handshake process and no prompt for open port. So ICMP error message for the closed ports are generally displayed, and this is executed with the command SU. Capturing a new session on the Wireshark again. This also requires root privileges. Capturing the data packets on Wireshark. A UDP scan, it generally shows the packet with a destination unreachable error message. So the ICMP error message gives the following. From now, my teammate Varun will take over.
Yeah, so as my friend mentioned before, the UDP scan doesn't require a handshake process, and we can see that the closed port produces an ICMP error packet, and how can an analyst determine where this error message belongs when there isn't any initial information about the error provided? So the original request is used as encapsulated data in the ICMP error message, which indicates the packet source and reason. Like if you open the ICMP portion of the packet details window, we can see both the original request and the wrap data. And so so the next task is reconstructing file from the captured packets. So first we have to download the evilputty.exe, and after downloading, just open with the browser, and later on we have to capture the files uh, from the browser, and after that we have to go to the file and export the object and select the HTTP filter, and we have to capture the objects from the Wireshark, and we have to verify that the file we exported from Wireshark and the file that we downloaded from our browser both matches or not. We can look for uh, files MD5 hash to verify its integrity, and we have checked the MD5 hash of and we can just match both the evilputty.exe using the MD5 sum tool, which will be included with Kali by default. So coming to the automatic remote traffic filtering, so the remote content must be transferred across the network if the Wireshark is operating remotely using, for example, SSH or an exported 11x11 window, a terminal server, etc. This adds a lot of typically irrelevant packets to the actually the interesting ones. So in order to prevent this, Wireshark automatically constructs a capture filter that matches specific elements of the connection and attempts to determine whether it is remotely connected by looking at some specific environment variables. So coming to the stopping and restarting the capture sessions. So a running capture session will be stopped in a few ways. One of them is like the stop capture button in the capture information dialog box. We have to then navigate to the capture, then stop menu item, and we have to click on the stop toolbar button. And the other one is like pressing Control E, like the capture will be automatically stopped if one of the stop conditions is met, like the maximum amount of data was captured is like one of the example we can state. So restarting a running capture session with the same capture options as the previous instance will delete all the packets that were previously collected. If some uninteresting packets are caught and don't need to be kept, this might be helpful. And restart is a convenience function that works similarly to stopping capture and then immediately starting it again. So there are a few ways to start a restart, like using the capture. Just go navigate to the restart menu item. From there, we can use the restart toolbar button. This is like one of the ways. So coming to the input and output of capturing data, like we have to just open the capture files in various capture file formats, then save and export capture files in various formats, and then we can merge all the capture files together, and uh, a warning prompts to save the current file to prevent data loss. So, and at last we can just print the packets. Okay, so here restore for the open capture files, restored capture files can be viewed by Wireshark. So for that we just have to choose the file, open from the menu or toolbar item to view them. The file open dialog box will then appear in Wireshark. If you haven't already saved the current capture file, you will be prompted to do so in order to avoid data loss. You may disable this warning in settings. Wireshark can read and write capture files from a wide range of different packet capture tools in addition to its native file format, that is PCAPNG. So coming to the saving capture packets, you can just save capture packets by using the file, then navigate to save or file and save as, and you can just click on like menu items. You can choose which packets to save and which file format to be used from there. So coming to the conclusion, so we investigated a potent tool for network analysis, monitoring, and troubleshooting. In this in-depth look at Wireshark, we talked about its capabilities, features, and functions, which includes live network capturing, like the real-time network traffic analysis, and the capture is possible with live network capture. Filtering to concentrate on particular traffic, filter packets according to the range of parameters, and to analyze protocols, and interpret and present comprehensive details about various network protocols. And the statistics include producing a range of statistics regarding the traffic that was collected, and exporting includes saving collected data in various formats for further examination. So we further looked into using Wireshark's filter expressions to identify particular scan types, such as TCP, Connect, SYN, and UDP scans. We also learned how to automatically filter remote traffic, reassemble files from recorded packets, and carry out crucial operations. So, all things considered, network security experts, network administrators, and anybody else interested in deciphering network traffic and resolving network problems will find Wireshark to be an extremely useful tool. This in depth look offers a strong basis for additional investigation and proficiency with this potent tool. So, these are the references that we used for this, and thank you. That concludes our presentation.